Well, you tell me where to start. Do we want to start at 1 and just go down?
Yeah, 1. I realized I did them backwards, though, after.
Well, good. I was just about to tell you that. In other words, second, just a moment.
And I'm not quite sure how to do 5 through set through.
Oh, okay, well, let's get this straight. Positive angles are measured counterclockwise. Negative angles are measured clockwise.
Okay.
Okay? That's all you have to know, really. Everything else, the size of the angle, you've got correct. It's just you went from the wrong direction.
Yeah, I noticed after.
All right. And there's a few problems with 5 also. If we have a 340-degree angle, if we want coterminal angles, we just add 360. If I want another one, add another 360. If I want another one, add another 360. If I want a negative one, then subtract 360. In other words, do 340 minus 360, which gives you negative 20 degrees. So one positive would be 340 plus 360. You've subtracted them here. You don't want to subtract them. You want to add them. So 700 would represent an angle that is coterminal with 340. You understand why?
No.
Because coterminal angles are multiples of 360. So you always want to either be adding or subtracting 360, not 340. What you did here was you put 360 above the 340 and subtracted the two, got 20. And then I'm not sure what you did there. So let's ignore what you've written because it's a little confusing. Let's go through it.
Yeah.
Let's go through it. Okay, here's our angle, 340. Now, if you want a negative angle, then subtract 360. What do you get?
Sorry, I just yawned.
All right. Just don't go to sleep.
I just woke up from a nap 15 minutes ago.
Okay. So it's 340 minus 360 is what?
Negative 20.
So there's one angle because they want a positive one and a negative one. So there's our negative one. Okay? Now, to get a positive one, we're going to add 360. What's that give you?
700.
There's your answers. 700 is a positive one, minus 20 is a negative one. Both of them are 360 degrees from 340. Just depends on whether you're adding 360 or subtracting 360. But it's always 360. In other words, minus 340 is not coterminal with 340. Not sure where you came up with this. Let's do another one. You'll get it. We keep doing them. That's why they have you do these. So let's start with 540. Okay? Now, that's not even inside the unit circle. At least my 340 was inside the unit circle, right? But 540, if I subtract 360, I get 180. Well, there's one angle. There's one answer. There's the positive one. Now, how would I get a negative one?
By subtracting?
Another 360. In other words, you can subtract as many 360s as you want. And that gives you minus 120. So there's our negative angle. So our positive angle is plus 180, our negative angle is minus 180, but there's lots of answers. In other words, I could have added 360 to 540 and gotten 900. That's also coterminal, and it's a positive angle, so that would have worked. I mean, that would have satisfied their request. So just know that coterminal angles are always separated by 360.
Okay.
In other words, is all you're doing is going around the circle again. If I start and I go around once, that's 360. Well, if I go around a second time, that's 720, but I end up in the same spot. If I go around another time, that's 1080, but I end up in the same spot. So these spots are all the same trig functions. So trig functions of coterminal angles are always the same. In other words, I would say that whatever if we take this first one, 340, the sine of 340 is going to be the same as the sine of minus 20. It's also going to be the same as the sine of 700. Remember, this was our positive one and this was our negative one. But as long as they are multiples of 360 away from the original angle, then all the trig functions are the same, not just sine, but the tangent. The tangent of 340 is the same as the tangent of 700. The secant of 340 is the same as the secant of 700. So coterminal angles are all just the same in terms of trig. Okay. Now let's look at this 20 pi over 3. That's in radians. Oh, I didn't look at your answer on number 6. You got it right. You got minus 180 and you got plus 180. Number 7, there's 2 ways you can do it. First of all, you can convert it to degrees and then do everything we're talking about only in degrees. But I don't know if your teacher wants you to do it that way. In other words, your teacher probably wants an answer in radians, correct?
I think so. I don't remember her
Let's do it in radians anyway. Okay? What is the equivalent of 360 degrees in radians?
Just pi?
2 pi. Pi is 180. 2 pi radians is 360 degrees. So I'm going to subtract 2 pi from this, which is the same as 6 pi over 3. And the reason I made it this is so I got a common denominator. Okay? Now, that answer is 14 pi over 3. So there's the positive angle. That works. Now, if I want to get a negative angle, I just keep subtracting 2 pi from that. So I got 14 pi over 3 minus 6 pi over 3. That's 8 pi over 3. I'm going to subtract another 6 pi over 3. That's 2 pi over 3. There's another positive angle that's the same as 20 pi over 3. But if I want a negative angle, I got to subtract one more 2 pi, which is 6 pi over 3, and that gives me minus 4 pi over 3. There's the first negative angle that I found. And as all I did was I kept subtracting 2 pi.
Okay.
Now, you don't necessarily have to do it as slowly as I did it. In other words, it's not terribly difficult for me to realize that 20 pi over 3 is like 6.5 pi. So I know I got to subtract quite a few 2 pi's before I even get into the unit circle. And you know what I mean when I say get into the unit circle?
Yeah, I think so.
Get it down below 360.
Okay.
Okay, because this is a big angle here. This is more than 6 pi. Well, 2 pi is 1 unit circle. So this is like in the 4th unit circle, 4th go around. And so if I realize that, well then maybe I'll try subtracting 6 pi right away. Well, 6 pi, or maybe even 8 pi. Let's see if we can get away with subtracting 8 pi. Well, we can't without going negative. But I could subtract 6 pi. Notice that 6 pi is 18 pi over 3. That immediately gets us to 2 pi over 3, which is not only a positive angle, it's inside the unit circle. Now, she doesn't say in the instructions that it has to be inside the unit circle. She just says find one positive and one negative. Well, there's a positive one, and if I want to subtract one more 2 pi, because this is in the unit circle, I know that if I subtract one more 2 pi, I'm going to have a negative angle. And sure enough, 2 pi over 3 minus 6 pi over 3, there's my 2 pi, gives me minus 4 pi over 3.
Okay.
All right. Let's look at 12 pi over 5. First of all, tell me, number 8, tell me, is that in the unit circle or not?
Yes.
2 pi is the unit circle. How many pi is that?
12.
It's 12 pi over 5. That's more than 2 pi. 2 pi would be 10 pi over 5.
Doesn't it go to 11 pi over 6?
No, well, no, the unit circle goes to 2 pi. 11 pi over 6, what you're talking about is when they slice up the unit circle, the last slice is 11 pi over 6. In other words, this angle right here is 11 pi over 6. But that's not a full unit circle. A full unit circle goes all the way back to the x-axis. That's 12 pi over 6.
Oh, okay.
Which is 2 pi. So 2 pi is the unit circle. Okay? All right. So is this, and if you don't know whether this is greater than 2 pi or not, but you should know that. You should be able to figure out that this is greater than 2 pi, just because 2 pi is 10 pi over 5, correct?
Yeah.
Well, this is 12 pi over 5. That's greater. So, let's start by subtracting 2 pi from that. And that's going to still give us a positive angle, and it's going to be in the unit circle, which is kind of nice. So what's 12 pi over 6, 12 pi over 5 minus 2 pi equal
to? 10 pi over 5?
So we got 12 pi over 5 minus 10 pi over 5. Yeah, I can write that as 10 pi over 5. Now give me the answer. What's 12 pi over 5 minus 10 pi over
5? 2 pi over 5?
Is that in the unit circle?
No.
Yes, it is. It's less than 2 pi. To be in the unit circle, you got to be between 0 and 2 pi.
Oh.
Okay? So, there's a positive angle. So that satisfies the one positive angle that's coterminal. Now, how am I going to get a negative angle?
By adding it?
No.
Or keep subtracting?
Keep subtracting. If I add it, I'm going to get back to the original. Right? In other words, I started with the original and I subtracted 2 pi from it. So you're not always adding and you're not always subtracting. What you're doing is it would be nice if you could get your positive angle in the unit circle. I would have preferred this problem say that. Find one positive angle in the unit circle and one negative angle in the unit circle. In other words, make these angles be less than 2 pi. Okay, well there's one of them. There's the positive one. And if I want the other one, then I'm just going to subtract another 2 pi. Or another 10 pi over 5. What's that give me?
Negative 8 over 5, negative 8 pi over 5.
8 pi over 5. There's my negative angle, and that is inside one unit circle if I go clockwise. In other words, this number is less than 2 pi. Very important to be able to determine whether a number is less than or greater than 2 pi. Since 10 pi over 5 is 2 pi, then 8 pi over 5 is less than 2 pi. That makes this in the unit circle and negative, and it makes that in the unit circle and positive. And those are my two favorite answers, although those aren't the only answers. In other words, to get a positive angle, I could just go up to my original one, 12 pi over 5, and let's add 2 pi. That's all I need to get a positive angle. And that will also be a coterminal angle. That is coterminal and it's positive. So I could have done it that way. I subtracted only because I knew I needed to get down to the unit circle and do one more subtraction to find my negative angle. So I went down rather than up. You see the difference?
Yeah.
If I'm adding 2 pi, then I'm just going around more and more times. Okay? If I'm subtracting 2 pi, then they went around twice to start. By subtracting 2 pi, I'm erasing that. So I get back to the original. The key is knowing the unit circle is 0 to 360 or even 0 to minus 360. In other words, the unit circle, if I go counterclockwise, that's 360 and also 2 pi. But if I go clockwise, these are negative angles. All of these are negative angles. There's negative 360. Well, I kind of consider negative angles that are less than 360 also inside the unit circle. So if you're trying to find a positive and a negative, work towards the unit circle. Once you get your positive angle inside the unit circle, subtract 2 pi from it, and you'll have your negative angle.
Okay.
Again, I could subtract another 2 pi from that and have another negative angle. In other words, minus 18 pi over 5 is also coterminal. It's just not in the unit circle. So I don't like it as much. I prefer, like I said, this would have been a better question had she said, make sure your angle answers are inside the unit circle, either positive or negative. Okay.
So now we're on 9, it looks like.
Yeah. Trying to figure out if I want to give you my easy method. I think I do. And for me to give you that, let me do this. There are some relationships that you want to memorize. That's it, right there. Those two numbers multiply to what?
180.
Okay. Now pi over 3 equals 60. Those two numbers multiply to what?
180.
pi over 4 equals 45. Those two numbers multiply to 180. Pi over 6 equals 30 degrees. Those two numbers multiply to 180. You get the picture? You only have to memorize one thing, is that if you have pi in the numerator only, then the denominator times the degrees is your answer. It has to be equal to 180. Now, I know they give you a conversion factor, and we're going to get to that. But I'm giving you the easy method. Okay? Now, if pi over 3 is 60, what's 2 pi over 3?
Ooh, sorry.
Again, say it again. If pi over 3 is 60 degrees, what's 2 pi over 3?
120.
Just multiply 60 by 2. What's 4 pi over 3?
Um, 240.
If pi over 6 is 30 degrees, the bottom one, what's 7 pi over 6?
210.
See how easy this method is?
Yeah.
Okay. Now, this works going from radians to degrees. To go from degrees to radians, go ahead and use the conversion that they give you. In other words, if I'm converting 90 degrees, then what is my conversion factor? It's either pi over 180 or 180 over pi. What is it?
Pi over 180.
Because you've got to lose the degrees. In other words, the degrees go there, those are going to cancel, and you're going to be left with radians. And that's pi over 2, radians. So this is a universal conversion factor. I could have used this on my converting pi over 3. We now know that that's 60 degrees, right? But if I did it the book way, this is the way they would do it. Right? In other words, I gotta lose the radians, and that's radians, and that's radians. So the way to think about this conversion factor is whatever you're starting with, you're trying to lose. So those cancels, those have to cancel, which means in my denominator of the conversion factor, I got to have radians, and that's the one thing that goes with pi. Okay, and that ends up, the pi's cancel, and I end up with 60 degrees, because the degrees go with the 180. So you can use this universal conversion factor, as long as you can figure out which way it goes, and that's not hard to do. Just know that you got to lose what you start with. Here I got to lose degrees and pick up radians, and here I got to lose radians and pick up degrees. It's just that when I use this conversion factor, I end up having to do it on paper. I just do. Whereas when I do the method that I showed you, I can do that in my head all day long. So when I'm going from radians to degrees, I do it in my head. When I'm going from degrees to radians, I do it on paper.
Okay.
So, hold on. Let me get each of these up here, and then so I can write on this screen. All right, so let's do 9. Tell me what the conversion factor is.
Pi over 180.
It's 180. Always 180. 180 is the magic number in geometry, right? When you were doing geometry, everything adds to 180. The sum of an angles of a triangle adds to 180. Supplementary angles add to 180. 180 is a very magic number.
Uh-huh.
Okay? Well, in that conversion factor, it's always 180. Now, what's that equal to? In other words, let's do some arithmetic here. So here's what we've got. We've got 210 times pi in the numerator, and we got 180 in the denominator. Well, first thing I can do is cross off those zeros. So now I got 21 pi over 18. You need to simplify that. They're not going to like that as an answer because it can be simplified. What kind?
It would be 7 pi over 6.
That's the answer they're looking for.
Okay.
Okay. So all we're going to do is use the conversion factor on all of these. So give me the conversion factor again.
Pi over 180.
Now what we have is minus 340 pi over 180. Cross off those zeros. Simplify the 34 over 18.
So, would I divide by 2 this time?
Yeah, you divide by 2 and see what you're left with. In other words, if I divide by 2, I got 17 over 9. Now, can I break that down any further? And I can't. 17 is a prime number. So, yeah, if you don't know how to simplify something, always, and they're both even numbers, then always divide by 2 for starters. And then if you can divide by 2 again, do it again. And keep doing it till you can't do it anymore. That's one way to do it. Okay. So there is the equivalent angle of minus 340 degrees.
Okay.
Okay. Number 11. It's my conversion factor.
Pi over 180.
Now break this down. 165 pi over 180. What can I divide top and bottom by for sure?
5.
Okay. 5 goes into the top how many times?
33.
And the bottom?
36.
Oh, I can divide both of those by 3. What's that?
Okay, 11 over 12.
Okay. And
11 pi.
the easiest mistake to make here is to leave the pi behind. In other words, we kind of get caught up into simplifying that part of it. And a final answer, it's real easy to forget to bring the pi with you. Like a bad dinner guest showing up to a potluck without the pie. So, okay. I think you got the hang of this. So let's go on. Let's not keep doing stuff that I know you understand. Let's go to 13.
Okay.
Now, if I do it the hard way, what's the conversion factor?
Pi over 180.
Ah, this is different. This is going from radians to degrees. So this has got to be 180 over pi. Because remember, that's radians right there, and this is radians. And I want to lose the radians and pick up degrees. So when you're going from radians to degrees, it's got to be 180 over pi.
Okay.
Okay. And the pi's cancel. So you end up with 13 times 180 over 4. See how the pi's cancel one another?
Yeah.
Whatever this number is, well, 4 goes into 180 45 times. So whatever 13 times 45 is the answer. Do you have a calculator in front of you?
Yeah.
Go ahead and give me that number.
585 degrees.
585. Now, look at all the work we had to do, and we had to do it on paper. Now let's go back, and what was pi over 4? Angle. It's one of your common ones. In other words, your common angles are 30, 45,
45 degrees.
45, right? Is that what you said?
Yeah.
So pi over 4 equals 45 degrees because those two numbers multiply to 180. So what's 13 pi over 4 going to be? 13 times 45.
Which is what I just did, right?
5. Yeah, it's exactly the same thing you did. The only thing is that it seems easier to me to do it this way. As long as you know what that is, and that's pretty easy to know. In other words, that's not hard to know what that is. And your denominators here are always going to be 2, 3, 4, 6, sometimes 12, but not very often. In other words, they're not numbers like 7, which doesn't go into 180. So you can do these any way you want, but you can see that this was kind of a two-step process. I might have still needed a calculator to multiply 45 by 13, but most of these I'm not going to need a calculator. For example, the next one. What's pi over 3 equal to?
60 degrees.
So what's 8 pi over 3?
60 times 8, which is 40, yeah.
No pi. Sorry, I didn't mean to put that in there. And
okay.
You see how much easier that was? Because if I would have had to use a conversion factor, I would have had to multiply by 180 over pi. And that's going to give us the same answer, but I'm going to have to use pencil, paper, and a calculator to do that. I didn't have to use any of it to do it my way. I didn't have to use a pencil, paper. Hold on. There we go. In other words, as long as I knew what pi over 3 was, that's pretty easy to know, then 8 pi over 3 is just 8 times 60 degrees. Okay, let's do the second one. What's pi over 3 again?
60 degrees.
What's minus 2 pi over 3?
Would I just subtract or multiply 60 times negative 2?
Yep.
And negative 120.
Okay. Now pi over 12, notice we're looking at just a pi in the numerator, so whatever that's equal to, 12 times that number has to be 180. That number's 15.
Okay.
12 times 15 is 180. And
so divided by 12.
Yeah, I don't want to really confuse you. It might just be better to always use the official conversion factor here.
Okay.
Notice it gives you the same thing. The pi's cancel, and I'm left with 180 divided by 12. Well, that's what we did, was 180 divided by 12. That's how we came up with our 15 degrees in the first place. So you can use the conversion factor, and it might be safer to use the conversion factor on all of these, on all all problems from 9 to 16. It's just, to me, my way seems a little bit easier. First of all, it's rare you deal with that big of an angle. Usually you're dealing with these kind of angles or these kind of angles, which means by my way I can do it in my head. Or this kind of angle. And if I can do stuff in my head as opposed to having to write it on a piece of paper and then use a calculator, far better off. 1 minute. Let me close my door so my dog... Hi, come here.
Why is she barking?
I don't know. She seems to have this habit lately of right in the middle of a session, she starts barking. She came upstairs. Now she's outside my door saying, what'd you call me for if you're not going to let me in? She barks at just whatever noises. I live at the end of a cul-de-sac, so there's kids playing in the street. Who knows? All right, let's talk about arc length. Arc length is S, and S is equal to the radius times the angle if it's in radians. If the angle is in degrees, well then clearly you have to apply the conversion factor. That's in radians, and so the conversion factor would be that. So there's your two formulas for arc length. You know what I mean by arc length? Arc length is the distance from there to there. If this was a piece of string and you cut it and stretched it out, it would be the linear distance between there and there. That's the arc length.
Okay.
Okay? So all we got to do is plug into these two formulas, whichever one is appropriate. Well, on 17, which one is appropriate? First or the second formula?
Both? I don't know.
Just the top one. In other words, this is for radians, this is for degrees. Well, this first one, the angle was in radians. So we want to use the first formula.
Okay.
Okay, hold on. So the formula is going to be S equals the radius, which is 12, times the angle, which is 3 pi over 2. Well, what is that? That's 18 pi. That's the arc length, 18 pi for number 17. So it's real easy, as long as you remember these two formulas. So let's do 18. You tell me what to plug in.
S2 radian.
No? Is that measurement in degrees or radians?
Radians.
Okay, then we're going to use this formula. And theta is going to be whatever it is in radians. Well, it's 3 pi over 4 radians. So it's the radius times 3 pi over 4. Well, what is that? 3 pi over 2 inches. And the first one gave an arc length in feet, 18 feet. This one, because r was in inches, then the total length of the arc is going to be 3 pi over 2 inches. Now, the third one's a little different. What's different about the third one?
It's in degrees.
So which formula are we going to use?
The bottom one.
Okay, tell me what to write. What's S going to be equal to?
20, and then theta.
What's theta?
180 over...
No, theta's 180. There's theta right there. It's just in degrees. In the other two questions, it was in radians. Here it's in degrees. So since it's in degrees, we need to apply the conversion factor, which is, got it backwards. This should be pi over 180.
Oh.
See why? because the degrees always goes with the 180. So if I want my answer to be a number, then I got to get rid of the degrees. And those cancel. The degree marks cancel. In fact, the 180 cancels. My answer is 20 pi. And this one's meters. M is meters.
Okay.
So the units do matter. If you'd have left the units off here, you'd have probably lost a point or two on these problems.
Okay.
So you do need to remember to put the units in. They're making a point of changing the units with each problem. That was in feet, that was in inches, and that's in meters. So your arc length is a linear measurement. It's going to be in either inches, meters, feet, centimeters, whatever. All right. Evaluate those trig functions. Hold on a minute.
This is just a calculator, so I think we could skip them.
Well, to be honest, I hate you to do that because some of these you're supposed to be able to do without a calculator. And I want to show you how to do that. Okay, so I don't want to skip those if you're okay with that.
Yeah, that's fine. I thought we were supposed to.
Here's two triangles that are absolutely vital to know. If you want to do these common angles like 30, 45, and 60, those are the ones they expect you to be able to do without a calculator. Now, the best way to do them without a calculator is to memorize these two triangles. And when I say memorize, what I really mean is memorize the dimensions. With me?
Mm-hmm.
Tell me, looking at these triangles, tell me what the sine of 30 degrees is.
Does this have to do with SOHCAHTOA? Yeah.
Huh?
Okay.
Everything in trig has to do with SOHCAHTOA. SOHCAHTOA is not something you want to memorize. You want to know it like you know your name. Seriously.
Yeah.
You want to use it so frequently that you don't ever have to use the word SOHCAHTOA anymore. In other words, you want to use it until you know what sine is, until you know what cosine is, until you know what tangent is. So what's the sine of 30 degrees?
So the opposite of, I know the hypotenuse is always across from 90 degrees.
Opposite, right, and the opposite is opposite the angle we're talking about. Well, the angle I asked about was 30 degrees. So the side opposite 30 degrees is 1.
Okay. So 1 over 2?
1 over 2. So the sine of 30 degrees is 1/2. And that's not a bad one to memorize. That comes up a lot in trig. Okay?
Mm-hmm.
Now, what angle is number 20? It's not 30 degrees. What angle is it? Let's convert that to degrees. What do the degrees times the denominator have to multiply to?
60.
So pi over 3 is the same as 60 degrees. Now, go back and look at our triangle. What's the sine of 60 degrees?
Pi over 3.
No. Look at the 60-degree angle. What's opposite the 60-degree angle? What side?
The square root of 3.
And what's the hypotenuse?
2.
There's your answer. That's what the sine of 60 degrees is. Remember that we take trig functions of angles in order to get ratios.
Mm-hmm.
Now, sometimes those ratios will be whole numbers like 2 or 4, But usually they're ratios, they're fractions. So remember that we take trig functions. Doesn't matter which trig function. Any of the 6 trig functions, you always take it of an angle. Whether the angle's in radians or degrees, it's an angle. And what you get is a ratio of numbers. And the numbers you get from these 2 triangles. Now, just for a moment, look at these 2 triangles. Tell me what the tangent of 30 degrees is. Don't worry about rationalizing it. Just give me the ratio.
1 over square root of 3.
Good. What's the sine of 45 degrees?
1 over the square root of 2.
Good. What's tangent of 45 degrees?
1 over 1, so 1.
Good. See how valuable these 2 triangles are? And the thing is that these 2 triangles are going to answer all your questions about first quadrant angles. When you start dealing with second, third, and fourth quadrant angles, then there's a few more things you're going to have to memorize. But everything bases itself on first quadrant. So it's the first quadrant angles we really want to know. I want to know what sine of 30, sine of 45, and sine of 60 are. I want to know what cosine of 30, cosine of 45, cosine of 60 is. Okay?
Okay.
All right. Number 21, tangent of pi over 8. Well, pi over 8, pi over 4 was 45 degrees, right? So pi over 8 must be 22.5 degrees. Now, that one is not in our triangles. So that one you need to use your calculator. What kind of calculator, Emma?
Yeah, Inspire.
Okay, you have a trig key on there. You see it? Hit that key and up pops 12 different functions. You got your 6 trig functions and you got your 6 inverse trig functions. Choose the one that says tan.
Okay.
And type in, first of all, are you in degrees or radians in your calculator?
Degree.
Okay, type in tan and then put 22.5 inside the parentheses.
That's 0.41.
That's your answer. And I could only get it with the calculator because it wasn't one of my common angles. In other words, it wasn't 30, 45, or 60. Now, sine of pi over 2.
So that's 90 degrees.
Yeah. You know what? Let me teach you the best way of learning your quadrangles. Learning the quadrangles are important, but it requires me to use the unit circle. When I have a ray like that, this coordinate right there is x comma y, correct? But it's also always the cosine of theta comma the sine of theta. So have they asked you yet to memorize the unit circle? Is that something you're going to have to do?
Yeah.
Okay, then you need to know this for sure. In other words, the coordinate of my x there is not x comma y, it's cosine of theta comma sine theta. You with me?
Okay. Yeah.
Okay. Now, let's look at the quadrangles. quadrangles are multiples of 90. So the first quadrangle I'm going to look at is 0 degrees. Okay. What are the x and y coordinates of this point right there? This is the unit circle.
0, comma 0?
1, comma 0. You see why? It's 1 on the x-axis, but 0 on the y-axis. You clear as to why the coordinates of that are 1, comma 0?
Kind of.
Well, what are the coordinates of this point right there?
0, comma 1.
There you go. So, what are the coordinates of this point over here?
Negative 1, comma 0.
This is because we're on the unit circle, so everything is a length of 1. And finally, this one down here?
0, comma negative 1.
Okay. Now remember what I said? X was cosine of theta. The y-coordinate is the sine of theta. So, looking at 0, what is the cosine of 0 equal to?
I don't, do I type that in?
No. No, I want you to learn it without a calculator. The cosine of 0 is that coordinate. Remember, the x-coordinate is the cosine of theta. The y-coordinate is the sine of theta. So when I say what's the cosine of 0, it's 1. What's the sine of 0?
1.
No. What's the y-coordinate of this point?
0.
Correct. So the cosine of 0 is 1. The sine of 0 is 0. Now let's look at a 90-degree angle. What's the cosine of 90 degrees?
1.
No. The cosine is the x-coordinate. The sine is the y-coordinate. Get it?
0.
Based on this right here. So what is the cosine of 90 degrees?
0.
What's the sine of 90 degrees?
1.
Okay, now you got me. Now you got it. What is the cosine of 180 degrees?
Negative 1.
What's the sine of 180 degrees?
0.
What is the cosine of 270 degrees?
0.
Now what's the sine of 270?
Negative 1.
Yeah, correct. That's how you learn your quadrangles.
Okay.
The most important thing about your quadrangles is up here. It's knowing that the x-coordinate is the cosine of theta and the y-coordinate is the sine of theta. Now, let's go back and talk about the unit circle. This time I'm going to draw a 30-degree angle. Again, on the unit circle. So the length of that's 1. What that means is when they want you to memorize the unit circle, they want you to know what the x value and the y value is. Okay? They don't want you to just know what the sine and cosine of 30 degrees is. They want you to know what the coordinates are. Well, the thing you got to know is that the x-coordinate is the cosine of 30 degrees. The y-coordinate is the sine of 30 degrees. Cosine of 30 degrees for my two rectangles is square root of 3 over 2. Sine of 30 degrees, remember I said memorize that, that's 1/2. So when I'm drawing my unit circle, every coordinate point is cosine of that angle, comma, sine of that angle.
Okay.
Okay?
Where's tangent, though?
What's that?
Where's tangent?
Well, tangent is actually sine divided by cosine. So tangent is 1/2 divided by root 3 over 2. And if you do that math, you get 1 over root 3, which remember we got when we were looking at the triangles. In other words, there's our 30/60. The thing you got to memorize here, not that it's a 30/60, but what these three dimensions are. Notice what the tangent of 30 is. It's 1 over root 3. It's also the sine of 30 divided by the cosine of 30. That's a trig identity that you haven't learned yet, and you might not even learn this year. But
Okay.
so when they have you memorize the unit circle, I think the only thing you need is cosine and sine. Am I wrong? Do they want you to know
No.
tangent of all these angles also?
No.
Okay. Because,
I was just asking.
well, that's fine. The way I get tangent is by referring to that triangle right there. That's the way I get my tangent. But it is true that the tangent of any angle is equal to the sine of that angle divided by the cosine of that angle. So if you know all 16 points on the unit circle, and that's how many there are, 16, and you want to know the tangent, take the sine value and divide it by the cosine value. Just don't get these mixed up. The first one, the x-coordinate, is the cosine value, not the sine. A lot of people switch those around incorrectly. All right, so where are we at? We're doing the ones like pi over 2. That's where we left off. Hold on one second. So probably the best way for you to do these is to convert them to degrees, especially since your calculator is in degrees. So this is the sine of a what? What's pi over 2?
90.
What's the sine of 90 degrees? Do you remember from our unit circle?
The one we just did?
90 degrees is this angle. So
that's
what are the coordinates up there? The coordinates up there are 0, 1. So what's the sine of 90?
1.
You got it. Now, Emma, I'm going to have to run. I got a 6:30 appointment. Okay. And we're back on next week for Thursday. This was an unusual week, just because you have a test?
Yeah.
Okay. So
I'll see you Thursday at 4:30.
Okay, sounds good. Have a good week.
Thank you.
Bye-bye.